All right, so we want to sketch a function with all of these properties. So the first thing I always do is I always do asymptotes and points. I don't have any asymptotes listed here, but I do have 2 points. My first point is 1, 1, and my second point is 0, 0. So I'll put these 2 points on my graph. So I've taken care of this over here. Let's see what I can do next. I know that f prime 1 equals to 0. So the derivation at this point equals to 0, which means this is either a minimum, a maximum, or it can be also a stationary inflection point. Three possibilities when your derivative is 0. To figure out which one of the three it is, I have to look at my end behaviors as well, specifically the one on the right side. So it says as x approaches infinity, y is also approaching infinity. So let me draw that out. Very likely, and there's multiple solutions, you can draw it like this. So that's going towards infinity on both sides. And now I know if I want to hit this point, it's probably going to be a stationary inflection point. But also it could go up and then come back down. You could draw it like that as well. Let's not continue this part for now. Let's figure out the rest of the graph before we draw this because there's multiple possibilities over here. Okay, next thing I know is that when my f prime is greater than 0, when x is greater than 1. So I've already drawn that here. It's increasing when my graph is, when x is greater than 1, my graph is increasing. So I've taken care of this point as well. That's good. And that has to be the case to match with this over here. Let me look at the other end behavior. As x is approaching negative infinity, y is approaching 0. So I know that very likely it's going to be either from the top like this or from the bottom like this approaching 0. I just need to figure out which one of the two it is. Okay, so let me look at what else I have here. F prime 0 does not exist. So that again could have multiple possibilities at this point, but it could be a piecewise function. It could be a corner as well. And then the first point, f prime x is less than 0 for -3 less than equal to x less than 0. So I know that my derivative is negative from -3 till 0. So I know that it's going to be decreasing over here. So again, I have a couple of options. I could do a piecewise function, or I could also do corner over here. So let's make it a corner. And then let's, I can extend this a bit because it doesn't really matter. It doesn't tell me anything after that. And after this corner, I'm going to just make it rebound back, come back here, and then hug the asymptote like that. So that's one possibility. You could always do it in a lot of different ways. You could draw this as a piecewise function, start on the top, and just make it decrease and then hug that as well. It's not really an issue. So now we just need to fill in the middle stuff over here. Remember, I've taken care of this point over here. I've taken care of both end behaviors. So I just have to take care of these 2 points and affect the middle over here. So I'm going to flatten this out. This is a stationary inflection point, and it takes care of this. And now I just have to take care of this where f prime 0 does not exist. So to do that, again, there's multiple things you can do, but I'm going to just go down over here. Then I'm going to make that into a corner. And there's no derivative for any corners. So this is one possible solution for this graph, but again, there's pretty much infinite solutions here. A lot of people would actually make a piecewise function for this as well. And instead of doing this little thing in the middle here, they would just make it piecewise. They would just make this connect to this like that. So I'll show you a really sketch really quick. They would just make this connect to this over here, and then they would just make this part piecewise, so the derivative would not exist. And then they would just continue the function like that. So this is another very common answer as well to the same question.